What up? Here we go. We're going to skip some of the notes and get to the nitty-gritty. You ready? Today we're going to graph cosecant and secant. It's almost impossible to do. How would we even figure it out? I asked myself that question a few years ago when I started teaching. How will I ever teach kids how to graph that? Seeing how I don't even know how to do it. So I was like, how could I do it? Because I didn't know how. Because I never learned. So I decided to graph y equals sine of x. Because they're reciprocals, aren't they? So let's just start by graphing sine. The amplitude of sine is 1. So I go up to 1 and down to -1. And I thought, okay, the sine graph stays between there, and the period is 2 pi. I divide it into 4 parts. I decided to graph sine just to see what it looks like, see what I could learn from it. Where do I start? Center. Oh, you guys are smart. And I dashed the graph because I was like, that's not the actual graph of cosecant. I know that. It's the graph of sine. But maybe I can use something about the graph of sine to determine the graph of cosecant. Because I know the relationship between cosecant and sine. They're reciprocals of each other. So I started to look at the sine graph and say, hey, sine is equal to 0 right here. What is the reciprocal of 0? Undefined. So if sine's equal to 0 there, that means cosecant's undefined. What do we draw if it's undefined? A vertical asymptote. If you haven't watched the tangent cotangent video yet, then that's why you don't know this. And sine's equal to 0 here. So that means cosecant would be undefined. So I draw another vertical asymptote. In fact, anywhere where it crosses the x-axis, I'm going to draw this vertical asymptote. And I realized after I sketched this, I said to myself, wow, I've learned something really important about the graph of cosecant. However, I still don't have anything that's the actual graph of cosecant yet. I just got a lot of stuff up there, right? And then I went up here. I said, well, I know that sine's equal to what at this spot? What's its height? And what's the reciprocal of 1? 1. So like, oh, they both go through 1 because the reciprocal of 1 is 1. And then I traveled a little bit to the left, and I got to a green spot right here on the graph. Is this a big value or a small value? Small value, right? Like it's a really low number, like say maybe like 1 over 20 or something like that. Like it's a small number, right? What's the reciprocal of a really small number? So although sine is really small there, cosecant is really large. And if you go over here, again, sine is a very small value. So that means cosecant is a very big value. Like, well, that will be the same thing over here then. Sine is -1 down here. What's the reciprocal of -1? -1. So it shares that spot and then goes down. And all of a sudden, I've got a cosecant graph. Never knew anything about it, but I knew the graph of sine. Once I was able to graph sine, the rest of it, piece of cake, upside down, right? So instead of graphing secant, I should graph cosine. So I'll make a tick mark at 1 and at -1. Go ahead, quick sketch cosine. What's your favorite kind of Gatorade? Really? Yellow, huh? Purple? G2 purple specifically? I like cool blue. Better than the glacial freeze or whatever they call it? GG2? Wow, you know way too much about this. It does. Okay, all right. Cool. Really? What is G2? Is that like fewer calories or something? When I was younger, I thought Gatorade was like this magical thing. If you like drank it, you'd all of a sudden have like just amazing athletic abilities, because that's like what they showed on the TV commercials. That'd be facts, but it's not facts. Okay, awesome. We've got this. So then, what do I do next? Do you think? Vertical asymptotes wherever it crosses over that spot. And I draw these U-shapes at the maximums and minimums. Now, some of you might say, well, Mr. Gens, it's really not, I mean, come on. It's just a bunch of garbage up there. Like, what does the real graph look like on our calculator? Well, I did that for first hour. I'm going to say that it's pretty much identical. Yeah, for real. Facts. On God. Bro. Mid. What do you think about that, Maddie? Maddie, what's your perception of me back in high school? Do you think I was a nerd? Think I was cool? What do you think?
I think you were athletic.
Really?
Yeah.
All right. Emma thinks I was athletic for my school because I went to a tiny school. We were no good. Which, by the way, one of the tiny schools that we played against, they just played Hopkins in basketball last night. Hopkins is ranked 7th in the nation. They beat them.
Oh.
Yeah.
No.
Oh, Emma, you're a hater. Wow, how do I handle this? Kick her out of class?
Yeah.
Okay. No, I will tolerate it. I will allow it. You have time to change your mind. Maybe I could prove to you. Maybe.
Do you have like
Evidence? Sure. Yeah, I could show you. Yep. Okay. Looks like I need to earn some respect. No respect. Y equals, what do you think I graph? I'm not going to graph -3 secant of 2x. -3 cosine. This does not have a horizontal shift. It does not have a vertical shift. But I can identify the amplitude and the period. What is the amplitude? It is 3. What is the period? Pi. So I'm going to go ahead and I'm going to mark off 3. I'm not going to put 3 at the top because I need room for my U-shapes. So I'm going to go 1, 2, 3. 1, 2, 3. Where do I start? And where does that start? Bottom because of the negative. Very good. Now what? According to Emma, your smartness depends on which school you went to. No, I don't. By the way, I love your sweatshirt today. It is wonderful. I think we got most of the signatures done during our class.
This side.
Yeah. Yeah. So I'll reach out. Lily's dog died. She had to put her dog to sleep. And she's in my flex, so I got her a gift. Got her Almond Joys, Kissinger. And I got her some brownies. And I got her a card. What? Yeah, and I actually got something for Miss Kissinger too, because she's really nice. Oh. Oh, sad day. Poor dogs. Poor us. It's a little aggressive, Allie. Okay, that's like, it's like. Here we go. Oh, just think of all the things you guys learn in this class that has nothing to do with math. Last one. Look at this function right here. What I love about this last problem is it puts together so many aspects to graphing and mathematical knowledge over the years. And if we would have started with this at the beginning of this unit, you would have said, I have no idea. You maybe would have said, oh, it's shifted up to and it's a reflection. But otherwise, you would have no clue. And now we're going to do it. We're going to do it accurately and we're going to do it quickly. You really have learned a lot. You ever get frustrated, you show up to class, you're like, I already knew that. I don't think I learned anything new today. You do understand, you're learning new stuff all the time. Okay? May not like it. You may love it, but it's brand new. I'm going to start by graphing y equals -4 cosine of 2x plus pi over 2 plus 2. I have the vertical shift. I have the amplitude. I have the period. And I have the horizontal shift. That's where I start. Vertical shift. 2. Amplitude. 4. So what is the maximum value of the graph? 6. What's the minimum value of the graph? -2. So I'm going to go 2, 4, 6, because remember, I have to make space so I can see those U shapes. And then I go down 4. So the minimum value, as you said, is -2. That's the vertical structure of my graph. That's one thing I'm going to be looking on your test, is make sure that you have the vertical structure set up correctly. Any questions there? Okay, the period, pi, because you take 2 pi divided by 2 to get pi. I'm going to mark off pi right here. Pi over 2, pi over 4, 3 pi over 4. I always do. You do you. It's America. Now, true or false, there's a horizontal shift to this graph. There is. So the last new thing I'm going to teach you is how to avoid making a ghost graph for the horizontal shift. Because don't you think it would be frustrating to make a ghost graph and then a second ghost graph? So let's just get rid of the ghost graph altogether. And you're like, how do you do that? I'll show you. We identify the horizontal shift by taking 2x plus pi over 2 and saying equal to 0. So we have 2x equals -pi over 2. What is -pi over 2 divided by 2? -pi over 4. So suppose that I didn't have a horizontal shift. Suppose that this horizontal shift was not here. where would you start this graph? At -2, and you would go up. Agreed? So what I'm going to do is, instead of starting at -2 going up, I'm going to start at back here. I'm going to shift it one spot to the left, and that's my starting spot, and I go up. That's all you have to do. Now you might be like, Mr. Guest, why didn't you teach us that earlier? That would have been easier. I've done that before, and half the class gets confused. So I find it's better to just teach people that way and then show them here now so that they can avoid that. You don't draw your asymptotes where it crosses the x-axis. You draw it where it crosses the axis of rotation, that +2 for that shift. And that's that. Congratulations. Made it through a unit. This next test, I will be disappointed if we don't have at least half of the students get a 54 out of 54 on the test. It is doable. That's what's happened in previous years, and you guys are an extremely intelligent group. Your time to work.